Welcome to the course Fundamentals of Manufacturing Processes. In week 6 we'll talk about metalworking. This course is offered by Professor D.K. Dwivedi from Department of Mechanical and Industrial Engineering from IIT Roorkee. I'm your TA Alka Jange from IIT Kanpur. So first we'll go through some assignment questions, sample assignment questions, which will help you in solving your weekly assignments. And after that we'll go through some lecture notes. Okay, so first question is based on cold rolling. So for cold rolling operation, the angle bite is. So in case of cold rolling operation, you have lower angle compared to hot rolling. Okay, so it will be for all cold rolling operations, it is lesser than 30 degree. So 30 degree will be answer. If you have any query, you can unmute yourself and ask. So the bite angle in cold rolling is usually less than 30 degrees, and the bite angle is the angle formed at the center by the contact arc of the roll and the workpiece. And the formula for calculating the bite angle is theta equals to tan inverse under root r delta h divided by r minus delta h square. So here r is the roll radius. Okay, so always your this angle bite will always depend on radius of the roll, and also delta h is the reduction in thickness of the sheet. So in this formula, delta h is change in thickness after rolling, r is the radius of the rollers, and theta is the angle of bite. So using this formula you can calculate angle bite. Next question is a 25 mm thick plate is cold rolled using rolls of 500 mm diameters in a rolling operation. If the coefficient of friction is 0.14, the maximum possible draft is. Your options are 9.8 mm, 3.5 mm, 10 mm and 4.9 mm. So which one should be the correct answer? You can type it in the chat. Okay, which one should be the correct answer? So answer will be 4th. Okay, so for the maximum draft possible in case of rolling, it is given by the formula mu square multiplied by r. R here will be if we are going through lecture assignment questions. Okay, so here maximum draft is calculated using this formula mu square r. Okay, so in case of this, coefficient of friction is already given. So coefficient of friction all keeps on increasing with your increase in the temperature. So in case of cold rolling, it will be less, and as you increase the temperature, as you go for warm working and after that hot working, then this will keep on increasing. So that's why you will get higher draft, maximum possible draft in case of hot rolling. So in one go you can reduce the thickness of the sheet higher in case of hot rolling. In case of cold rolling, this mu square r, so r you have to calculate using the diameter that is given. So it will be half of the 500. So it will be 250 mm. So here square of 0.14 multiplied by 250. So it will be 4.9 mm. So 25 mm. Then after this reduction, you will be getting the final thickness. Okay, this is the amount of delta H. Next is Next question is, in Smith forging operation, fullering is done to, and your options are, fullering is one of the processes that is performed in case of forging. So you have to remember the some of the definitions that are there, some of the processes that are there. So in case of fullering, which process takes place? So your options are, reduce the cross section and increasing the length of bar, or increase the cross section and reducing the length of bar, or bend the bar, or the upset the bar. So which one should be the correct answer? So you can type your answer in the chat if you know the answer. Okay, so answer will be first one. Answer will be first one. So this is the fullering operation. The fullering is done to draw out the material, and in the fullering the material is distributed away from the forging area. So fullering is the process of reducing the cross section of workpiece or lengthening a preparation of the stock in preparation for the subsequent operation. So it is one of the middle process, it won't be the complete final process. So this is how your fullering operation will be performed. Next question is, press forging operation is. The options are, done in closed dies by a hammer in blows, or done in closed dies by continuous squeezing action, done in open dies by a hammer in blows, or done manually using open dies. So in case of press forging, so which one should be the correct answer? Answer will be continuous squeezing action. So there are various forging operations. So as I told earlier, you have to remember some of the definitions which will help you in answering these questions. Okay, so a forging press operates by utilizing a vertical ram to exert gradual and controlled pressure on a die containing a workpiece, and this method is akin to drop forging, but it employs steady pressure rather than repetitive blows, and the gradual movement of the ram allows for deeper penetration into the workpiece, resulting in uniform plastic deformation. So as seen here as well, this is the forging process. So your billet is kept on the anvil on the base, and then ram will be moving at a particular speed. Okay, so then after that you will be getting extra material in between that, and this billet will take the shape of the cavity that is provided here. The forging press dies come in two main types, open and closed. In open die forging, the die does not fully enclose the workpiece, whereas in closed die forging, also known as impression die forging, the die fully encases the workpiece. Forging presses that are used, can be either hydraulic or mechanical force to apply pressure, and mechanical presses, they utilize a flywheel to store energy, which is then transferred through a crank mechanism to move the ram, and these presses can deliver up to 12,000 tons of pressure. Next is, in the extrusion process, the extrusion ratio for metal varies from, your options are 2 to 5, 5 to 8, 8 to 10, or 20 to 50. So in case of extrusion for metals, so this extrusion ratio is mainly different for plastics. It will be different for your metals, in case of metals as well. If it is uh, hard metal or soft metal, that will also depend, but it will be covered in this particular range. So answer will be 20 to 50. So the extrusion ratio for metal in the extrusion process varies depending on the type of alloy being used. Yeah, correct answer. Okay, so this question, okay, someone else has joined. Okay, so we are going through lecture sample assignment questions, those who have joined late. So this question is dependent on the extrusion ratio for metals. So your options are 2 to 5, 5 to 8, 8 to 10 and 20 to 50. So as one of you have replied correctly in chat, so your answer will be 20 to 50. So in case of metals, it will be for hard alloys, they have extrusion ratio range between 10 is to 1 to 35 is to 1, and for soft alloys it varies between 10 is to 1 to 100 is to 1. So and the extrusion ratio, it is given as the ratio of initial cross sectional area of the billet to the final cross sectional area after extrusion. So R can be given as A naught upon AF. Okay, so 40 as to 1 for hot extrusion of steels, while 400 as to 1 for aluminum. So the extrusion ratio is a measure of how much mechanical work will be done on the shape as it's extruded, and a higher extrusion ratio means the part will be more difficult to extrude because of increased resistance to metal flow. And for example, a large diameter billet pushed through a small die opening has a high reduction ratio, which can be difficult to extrude. In these cases, you can try using a press with a smaller container or a multi-hole die that can extrude multiple profiles at once. Other factors that can affect a part's extrusion performance include size, shape, tolerance, and the finish that is required for the final product. Next is,
Ma'am,
yeah,
by 20 is, by meaning 20 is to 50 or 20 to 50.
yeah, 20 to
20 is to 1,
yeah, can you repeat?
by meaning 20 to 50, it's meaning 20 is to 1 to 50 is to 1.
Yeah,
Also, if the exclusion ratio is higher, means the value initial value will be higher. Like 400 is 1, we need to 400 is 1 means it will be we will be able to reduce it further to 1. I mean the smallest thickness possible, isn't it? So
yeah,
does that mean higher force need to be applied? Like for steel and aluminum comparison, steel will be having more force should be applied, isn't it?
yeah, correct. So if you have, for example, in case of soft alloys, you can go up to 100 values because you in one go you can reduce the size to a lot. So A naught upon AF. So initial will be less and final will be less compared to that, right? So you are dividing very higher value to lower value. So in that case, for soft alloys it is becoming very higher value, and if you go for polymers as well, then it can become very higher compared to even metals. So in case of hard alloys, you will be requiring a lot of pressure to even get very small extrusion ratio in one go.
Ma'am, so if you are saying about the force value, the extrusion ratio should be lower.
Extrusion ratio will be lower in case of what?
I mean, if you're comparing that aluminium and steel,
Hmm.
aluminium is having 40 is to 1 and 400 is to 1, and steel is having 40 is to 1. Uh, so we can compress it to smallest possible for aluminium than steel. So uh, the
No,
steel should
so
be given more force, isn't it?
okay,
In
so final
force.
area upon initial, right? So final area is, here you see the formula, right? So A naught is the initial area. So you will be having initial area very large and final area very small. Okay, so you are dividing that. So in case of aluminum, aluminum is very soft material compared to steel. So in that case, you can go up to very higher ratio compared to steel. Okay, so in case of aluminum you can go up to 400 in case of aluminum, while in case of steel you can only go up to 40. Okay, so as shown here, hard alloys you can go up to only 10 to 35, while in case of soft alloys you can go to 10 to 100 or something like that. Is it clear?
Okay.
Okay. Next question is, cast iron materials could be extruded by. Your options are backward extrusion, hydrostatic extrusion, impact extrusion, and cold extrusion forging. So which one should be the correct answer? You can type it in chat. Okay, so answer will be hydrostatic extrusion. So in case of hydrostatic extrusion, you can provide extra pressure compared to backward extrusion and impact extrusion, because in those cases you will be having to deal with the friction as well. In case of hydrostatic, it reduces that part. So hydrostatic extrusion is a metal forming process which uses liquid pressure medium to force a billet through a die, and this process can be used to extrude cast iron and has several advantages such as low friction, because the billet is separated from the container wall and plunger by fluid. There is almost no friction between them, and there is uniform force. The process applies a uniform force to the proximal end of the device. High pressure, so plastic deformation occurs under high hydrostatic pressure. Fast production, so hydrostatic extrusion can produce at faster rates than conventional direct extrusion. Even flow, the balanced distribution of force results in even material flow. So for example, in case of your, as I think I would be having a, yeah, here this is the direct extrusion. So in this case this is the dummy block. So here the material that is attached in middle will be having different flow compared to the material that is near this wall. So there will be laminar type of this flow in this case, and it won't be uniform as in case of hydrostatic. I think we have hydrostatic as well. Yeah, in hydrostatic, your container walls are separated from the billet. Okay, so with help of some liquid. So this liquid will be transmitting some pressure and exerting force on this billet. So there won't be any friction. Someone wants to join. Okay, so in this case, even flow will be there. The balanced distribution of force results in even material flow. Large billets, So hydrostatic extrusion can extrude large billets and cross sections. Hydrostatic extrusion can be performed in a variety of ways, including warm, cold, and hot. However, the temperature is limited by the stability of the fluid used, and the process must take place in a completely sealed cylinder. And the fluid can be pressurized in two ways: constant rate extrusion. So, a plunger or ram is used to pressurize the fluid in the container, and the constant pressure extrusion, in which a pump with a pressure intensifier is used to pressurize the fluid, which is then pumped into the container. Next question is second.
Ma'am, the other impact and other exclusions are removed due to whether the cast iron is brittle.
Yeah, can you repeat?
I mean, for the import and cold extrusion, is it avoided since the cast iron is brittle?
Yeah, yeah. Cold
Okay.
cold won't be providing you with much of the ductility here as well. In case of hydrostatic, you can perform it at lower temperature as well, but it is very much preferred for the cast alloys, this cast iron, hydrostatic extrusion. And also there is no friction that is acting as well in case of impact.
Ma'am,
Yeah.
by giving too much force, is it possible for the carbon inside the cast iron to precipitate or anything? Is that possible?
Carbon won't be precipitating, but it will. So in case of cast iron, if you are making using that billet, I think I should have the, yeah, here cold extrusion will be something like this and impact extrusion will be something like this. So you can perform that at higher temperature as well, but the problem will be the there will be friction acting as well, and there will be less ductility in case of cast iron as well. So in case of hydrostatic, that won't be a problem in case here. So your billet is not in contact with the container walls, it will only come in contact with the die.
Okay.
Okay. Okay, so next question is, yeah, sixth we completed. Yeah, for high reduction ratio 30 to 35% in wire drawing operation, the output product experiences. Your options are compressive residual stress near outer surface layer, or tensile residual stress near outer surface layer, tensile residual stress near central layer, or tensile stress near central layer. So which one should be the correct answer? So here you have to keep the image of this wire drawing operation in mind, like how wire will be squeezed into the die and how it will convert its size, and where should be the tensile residual stresses and where should be the compressive stresses. So the answer will be second one. Okay, so as a result of elastoplastic deformation during the wire drawing operation, the tensile residual stresses are generated near the surface in the axial and tangential direction, and balancing compressive residual stresses they form in the core. So as in extrusion as well, extrusion, okay, so it will be similar to this, but this will be a die opening rather than rollers. So in this part as well, you can see the more material will be squeezed and where should be the compressive part. So in center line, in case of wire drawing, you will be having compressive stresses, and at the outer part there will be tensile stresses. So next question is, in a wire drawing operation, a 10 diameter of a steel wire is drawn through a die to reduce the diameter by 20%, and the average flow stress of the material is 400 MPa, and the true stress required for drawing is, so your options are 89.25 MPa, 8.97 MPa, 178.5 MPa or 357 MPa. So the answer will be third one. Okay, so for this, here you have to remember the formula for true stress. So true stress will be here sigma F, which is already given, flow stress times the ln A naught upon AF. So A naught will be initial area and AF will be final area. So area meaning cross section area. So here first you have to calculate the radius. You can either calculate directly via diameter. So pi r square will be the cross section area, initial and final. So it's given 10 diameter is reduced to 20%. So after that, using those you calculate the area, and sigma f is already given in 400 MPa. So 400 times ln 100 divided by 64, it will be giving you 178.5 MPa as the true stress. Next is type of bulk forming process in metal forming is, your options are rolling, coining, punching and blanking. Someone has joined. Okay, so answer, type of bulk forming process in metal forming is, your options are rolling, coining, punching and blanking. So which one should be the correct answer? So answer will be rolling. So other these three processes, they are sheet metal working. Okay, so in case of coining, punching and blanking, these are sheet forming processes, while rolling, extrusion, forging, wire drawing, these are bulk forming processes. So in case of bulk forming, it is severe plastic deformation process resulting in massive shape change, and the surface area to volume of the work is relatively small, mostly done in the hot working conditions. So some of the important operations in bulk forming are rolling, forging, extrusion and wire or rod drawing. In case of rolling, in this process the workpiece in the form of slab or plate is compressed between two rotating rolls in the thickness direction, so that the thickness is reduced, and the rotating rolls draw the slab into the gap and they compress it. The final product is in the form of sheet. In case of forging, you have wide variety of products compared to rolling. So here the workpiece is compressed between two dies. It can be open forging as well. Okay, it can be open forging as well, in which you don't require any dies, closed dies. So in that case, the workpiece is compressed between two dies containing shaped contours, and the die shapes are imparted into the final part. You have extrusion, in which the workpiece is compressed or pushed into the die opening to take the shape of the die hole as its cross section. So in case of extrusion, entire cross section will be uniform. In case of wire drawing, you have cylindrical wire already and you will be reducing its diameter subsequently. Rod or wire, that will be initial stock. So similar to extrusion, except that the workpiece is pulled through the die opening to take the cross section. Next question is factors to be considered for the selection of press. Your options are tonnage.
Uh,
Yeah,
that surface area to volume ratio for coiling and punching and for those it will be higher. Surface area to volume
yeah,
ratio.
yeah.
Okay.
So the stock that you are using, that will be also in sheet form rather than having it in volumetric shape. So in case of, for example, in case of this rolling as well, you can use billets or thick sheets compared to these coining and punching and blanking. And the operations are also uh, different compared to these operations.
Okay. Ma'am, this embossing also came in the sheet metal form.
Yeah, can you repeat?
Embossing, embossing,
Embossing.
uh, embossing. The coining.
I don't know which process you are talking about because I have not heard that. You just
Okay.
check which process it falls in, like bulk forming or sheet metal forming, and you can read the definition, and then based on that you can decide like which one it will be under, like bulk forming or sheet metal forming.
Okay.
Next is factors to be considered for selection of press. So your forging press will be selected based on various factors. So it can be depended on either tonnage, number of strokes per minute, bed size, or all of these. So here answer will be all of these. So in last chapter I think sir has told about various presses. So in that he has also told like selection of presses, it depends on various factors. So when should we select, why do we require to select these presses? Because when you are purchasing some new press, then you need to you need to first understand like what is the size of stock, or what are the strokes per minute that are required, what is the amount of production rate. All those will be helping you in deciding which press to purchase, and then choose one from available presses. Now which are the availability, based on that which one will be suiting you best. And also the major considerations in selection of press includes tonnage meaning amount of the stock, and speed or stroke per minute, bed area. In some of the C section type ones, you'll be getting smaller area, C type, and in case of straight one you'll be getting more bed area. Shut height adjustment, stroke, travel of frame, number of presses, operations required. These are some of the type of some factors that you will be requiring when you will be selecting press. Next is we'll be going through some lecture assignment questions, but before that I'll repeat the questions once more briefly. So first question was based on angle of bite for cold rolling operations. So in case of cold rolling operations, it is less than 30 degrees, and the formula for this is given here. So you can be asked to calculate the angle of bite as well based on the roll diameter and the maximum draft delta H. Next is next was the numerical based on what is the maximum possible draft based on coefficient of friction and roller diameter. So roller diameter is given and coefficient of friction is given. So the formula is given as mu square multiplied by r. So r you already know, mu you already know. And here also one thing you have to remember, that coefficient of friction changes with the temperature as well. So for warm working and for hot working it will become higher, so you can achieve higher draft in case of hot working. Next is, in Smith forging operation full ring is done to reduce the cross section and increasing the length of bar. So it is one of the processes in which you draw out the material, and here material is distributed away from the forging area. Next question was, press forging operation is, so it is done by continuous squeezing action in closed dies. Okay, so this one would be the correct answer. Next was extrusion process. Extrusion ratio for metal varies from, so answer will be 20 to 50. So it depends on material that you are using, the extrusion ratio, and also the higher the extrusion ratio it will be for softer alloys. Okay, so it will be the initial area divided by final area. So final area will be of course smaller compared to initial cross section area, so it will be a positive number. Next is, cast iron materials could be extruded by, so cast iron materials they could be extruded by backward extrusion, hydrostatic impact, or cold extrusion forcing. So it will be in case of hydrostatic extrusion. So in case of hydrostatic extrusion you can go up to very high pressure, so it can be also used for cast iron, and also it has various advantages such as low friction and uniform force, etc. Next is the high reduction ratio 30 to 35% in wire drawing operation, the output product experiences. So your options are compressive residual stresses and tensile residual stresses near the surface or at the center. So the correct answer will be tensile residual stresses near the surface area. So at the inner part you will be having compressive residual stress for compensating this. Next is, in wire drawing operation you are given initial diameter and final diameter and also average flow stress, and based on that you have to calculate true stress. So firstly, true stress formula will be sigma f flow stress times the ln a naught upon af. So area you can easily calculate by pi r square, and based on that you will be getting the value of 178.5 MPa. Next question was, type of bulk forming processes in metal forming is. So here only one process is bulk forming and remaining are sheet metal forming processes, and this will depend on the surface area to volume of the work, which is smaller in case of bulk forming while it will be higher in case of sheet metal forming. And extrusion, rolling, forging, wire drawing, these are the bulk forming processes. Next question was, factors to be considered for the selection of press. So all of these will be the factors here. Now first chapter is based on rolling. Okay, so these are various terminologies that are given based on the size of the your ingot. So if it's 6 by 6 then it will be called blooms, and if it's 1.5 by 1.5 then it is billets. Slab will be, it will be rectangular rather than having a square type of shape. So here these are converted into different shapes and the thickness is reduced in case of rolling. So here we'll talk about this change in structure after some few slides. So firstly, these are the various parameters here. So theta will be your contact angle. Here, when you assume with the when you are trying to find some relations, then you make these assumptions that you have infinite sheet, you have uniform and perfectly rigid rollers, and you have constant material volume. So in this side you have thickness, width and length that you are providing of the sheet that you will be getting on the other side. So here initial thickness, initial width and initial length will be equals to final length multiplied by final thickness, final width multiplied by final length. Now this length can be changed into the rate as well. So V will be the velocity, plate entry speed, and Vf will be the plate exit speed. Okay, and other some of the parameters are also given here. So which are this roll speed, contact angle, contact length and roll pressure and roller radius. Now draft is defined as the reduction in thickness. So here T naught and Tf. So difference in this will be your draft, and maximum draft will be draft limit or maximum draft is given as m square r. M is mu. So mu will be 0.1, around 0.1 for cold rolling, 0.2 for warm working and 0.4 to 1 for hot working. So here this if maximum draft you can calculate based on the roll diameter. Next is define forward slip. So slip is also one of the formula that you can remember. It is Vf minus Vr divided by Vr. So this will be slipping of the sheet on the rolls. Next is these formula also will be helpful in solving some some of the questions. So we already used true stress, but true strain formula will be Ln T naught upon Tf. Okay, so T naught Tf is initial thickness divided by final thickness, and average flow stress it will be K. K is your constant. Then okay, so K will be your constant, E epsilon times N. E is your strain, true strain times the N. N is again your N will again be given, and okay, next I think you are given you have to solve. For example, in some questions you will be given the value of N such as 0.15 or such, and mu is already your coefficient of friction, so this will be also given. And here you are given a roll force, you can figure out using this formula. L is contact length, torque and power, all these formula. So first you have to find out initial strain and flow stress. Using these you can find out final power and torque. Now how the microstructure will change after rolling. So initial, if you are given this type of either elongated microstructure or equiaxed microstructure, so equiaxed structure of austenite, it will be changed into elongated microstructure after it is put through rolling. Okay, and here we are providing heat through the rollers as well. So this entire is in some you are providing high temperature as well. So that's why you are getting some dynamic recrystallization. So these grains which are elongated, they will turn into some equiaxed grains after dynamic recrystallization. So why recrystallization will occur? Because you will be providing some of the activation energy in form of plastic deformation. So this will lead to formation of some equiaxed grains as you keep on providing some heat. So first is hot rolling. So it enhances plasticity and efficiency. So in case of hot rolling, it is primarily conducted at high temperatures and is commonly used for producing thick plates and structural steel. And this method improves the metal's plasticity, reduces deformation resistance, or also enhances production efficiency. It also lowers costs. So in case of cold rolling, you will be requiring higher pressure, higher forces, and also your rolls will get damaged higher compared to hot rolling. That's why it will be having lower cost, and also it improves workability. In case of hot roll products, they may have relatively rough surface. So at higher temperatures, there will be change in microstructure at the surface as well. There can be scale formation as well, some oxidation which can lead to rough surface. And due to the shrinking during the cooling processes, dimensional precision may be compromised. Also, hot rolling possesses challenges in precisely controlling the mechanical properties of the products and may result in the compression of non-metallic inclusions, leading to layering phenomena that can affect the steel's performance. In case of cold rolling, precision and mechanical performance. So in case of cold rolling, you will be getting more precise and more higher tolerance compared to hot rolling. So in case of cold rolling, performed at room temperature is often employed as a subsequent processing step for hot roll products. And cold rolling enhances the material's mechanical properties and dimensional precision, resulting in smoother product surfaces. However, cold rolling can also induce work hardening in the material, leading to reduced stamping performance. Furthermore, cold rolling products typically exhibit higher strength and hardness compared to hot roll products, but with lower toughness. So because of the structure in case of cold rolled, it will be very elongated grains. So those elongated grains will give you anisotropic properties as well as very high density of dislocations, and high density of defects will lead to reduction in toughness of the product. Next is forging. In case of forging, there will be application of force on metal to cause plastic deformation so as to get the required final shape. So generally a hot forging, but can also be performed in cold conditions. So in case of hot forging, you will be providing a temperature above the recrystallization temperature to the workpiece. Now forging can be done in two ways, drawing out or upsetting. Okay, so in case of drawing out, the as shown here, so it elongates the object with a reduction in the cross sectional area, and here force is in a direction perpendicular to the longitudinal axis. In case of upsetting, it increases the cross sectional area of the stock at the expense of its length. And the as shown here, before your product was in this shape and after it has gone in this shape. So the force is applied in a direction parallel to the length axis. Now types of forgings: smith forging, trough forging, press forging, and machine forging. Now in case of smith forging, it is performed using open dies using manual or powered hammers. So as shown here, this is the example of smith forging. Trough forging, it uses closed impression dies by means of drop hammers in a series of blows. In case of press forging, it is similar to drop forging with the difference that the force is continuous squeezing type. So there will be a continuous change in the ram speed or RAM will be at a particular speed, and it will be squeezing the material in the cavity compared to drop forging. In case of drop forging, you will be providing blows with the help of hammers. Next is machine forging. Yeah,
All these forging processes are hot working or cold working process.
they
Smith
can be
forging
both.
and
As I told earlier, right? It can be cold forging as well. It can be hot forging as well, cold forging as well, but depending on the material. Okay, so for example, some of the steels, they are worked in case in austenite phase. So for austenite phase, you need to provide a particular temperature to that. Okay, so because at that particular temperature, it can be changed into shape easily. So it depends on the temperature, how which temperature you want to provide your material, and what final shape you require, and there are various factors that come into picture when you are deciding whether you want to go for cold forging or hot forging.
by meaning the oscillating temperature means 727 or 910.
Where you'll be finding the austenite phase.
Yes, I mean
It will be
the temperature
different for different steels depending on the amount of alloying elements.
is that will be the recrystallization temperature will be greater than the melting point temperature or lower than the melting point temperature.
It will be lower than melting temperature. All these processes that we are reading, these are being done below melting temperature, of course. The only metal working processes will be done below melting temperature, and about recrystallization temperature is zero point 0.3 times the melting temperature. Okay, you are multiplying your melting temperature in Kelvin to the zero point 0.3, then you will be getting recrystallization temperature.
So this will be in the range of 700 to 900 range. That oscillate by meaning seeing it in the red hot condition, it will be in the oscillate.
Yeah, yeah, yes.
Okay.
Okay, so next is machine forging. In case of machine forging, the material is only upset to get the desired shape using a set of dies. Now in case of machine forging, you will be having two different dies. So the base die will be on anvil and upper die will be attached to the ram. So ram will be traveling at a particular speed, and in between this you will be keeping your workpiece or billet. So after that, a squeezing type of action you will be providing, and this will be taking the shape of the cavity, and there will be a discard material will be also attached to it. This will be flash, so this will be removed through machining. So this is the finished piece with the flash. Next is
And
yeah,
how this coloring process and extrusion process different? And
soldering and which one?
extrusion. Extrusion.
Extrusion is different, as in case you are providing particular temperature. So extrusion, you are squeezing your material through a particular opening. Here you are providing particular the using hammering or using this ram speed in between die, you are providing shape to the material. You are providing the shape of the die, not. And in case of extrusion, see here, you are passing your material or billet through a particular opening. Okay, a particular opening, so you will be getting the final shape as the uniform cross section. And in case of this die, this can have these type of shapes as well in case of forging. So it will, these are very different processes in that case.
So now I mean about the fullering process. There was a fullering reduction of the diameter, isn't it? Not the forging, the fullering process.
Fullering the forging, subset of forging.
Okay, so it need not be in the final form. It will be the preliminary form.
Yeah, whatever you are getting, you can provide other processes to it as well, which are part of forging. It won't be final process. You are reducing the size of the in at the edges. You are reducing the size of the your billet or something in those lines.
Okay.
Okay, so in case of smith forging, it involves heating the stock in the blacksmith's hearth and then beating it over the anvil, and the stock is manipulated in between the blows and used for the low volume production of variety of designs. So in this case, how the open die forging process affects the crystal structure. So initial grain size, coarse grain structure was, if it was in this case, then after you provide some forging, then this becomes in a particular elongated type of structure. So plastic deformation and elongated grains will be getting, which will be providing you very high strength in particular directions. And also if you are providing temperature, high temperature to it, or in case of hot forging, or you are providing heat treatment, then it will change into aqueous type of grains. So growth of new fine grains can also occur. Next is drop forging. Yeah.
By increasing the length of the grains, it will be increasing the tensile force, but whether it will be low strength in the lateral direction.
Yeah, more strength will be in which direction, so it will be depending on the size. So if you see in this direction, uh, the pointer, okay, so if you are applying your tensile force in this direction, then you will be having the amount of more number of grains in this direction, while in this direction if you are applying tensile strength, then less number of grains will be there. So it will depend on the grain size. So grain size in this direction will be smaller compared to in this direction. So in which direction you have smaller grain size, you will be having higher strength in that particular direction.
So smaller grains means higher strength.
Yeah, smaller grains will be having more the interconnection between the grains as well. So grain boundary area will be higher in that particular direction. So grain boundary area will always provide you with the you Hall page relation will also give you this particular like in lower the grain size, higher will be the your higher will be the strength.
The elongated grains will reduce the strength.
It won't be,
Elongate.
no, it will be providing you anisotropic behavior, but which if you are comparing it to the coarser grain structure, then compared to that it will be having better strength properties. But if you are comparing it to aqueous very fine grain size, then compared to that it will be having inferior properties. So it depends on what you are comparing it with.
Okay.
Yeah. Next is drop forging. So in this case, die consists of two halves, and the other lower half is fixed to the anvil of the machine, while the upper half of the die is fixed to the ram. And the heated material stock is kept in the lower die while the ram delivers 4 to 5 blows on the material and in quick succession, so that the material spreads and completely fills the die cavity. When the two die halves close, the complete cavity is formed, and the machined impression in the die cavity also can help to get more complex shapes in the drop forging as compared to smith forging. So when you're using, for example, this is the die, in this you can provide some projections as well, which can provide a complex shape to the final product here. Okay, now these are some of the products that can be made using drop forging. So uh, these are the processes. You have provided workpiece, then with the help of hammering you will be getting the final shape, and this flash will be discarded afterwards. So, and this is the before, during and after drop forging. So this crankshaft or these various parts of the automobiles, they can be formed using forging. Now the applications. So typical products that are produced by drop forging are crankshaft, connecting rod, wrench, crane hook, etc. And the final shape desired in drop forging, it cannot be obtained directly from the stock in a single pass. And depending on the shape of the component, the desired grain flow direction, the material should be manipulated in a number of passes. Now here first, cold forging, these are the types of structures that will be there. So there is a granular flow that will be there in microstructure. So in cold forging you are not providing any uh, dynamic recrystallization. So here you will be having highest strength. In case of hot forging, you are relieving some of the stresses, residual stresses, and you are also reducing the dislocation density. So it will be having high strength, lesser compared to the cold forging. And in case of machining, you will be having lowest strength.
Ma'am, for the cold forging process, is there any possible, like for bending operation, there will be a spring back return will be coming. If you remove the force, will the cold forging can cause similar effect?
No, but in case of cold forging, you are applying multiple blows to the your cast, your this billet, right? So you'll be considering those type of defects, and depending on that, you can provide allowances as well. So some defects will be there as well. So I think they are given here as well. So these are particular defects that are found in this forging as well. So it won't be depending on whether cold forging or hot forging. It will be like more dependent on how much you are taking those in consideration, like whichever. But spring back type of effect, that won't be here.
Okay.
Okay, next, these are some of the steps in the forging: stock filtering, edging, bending, blocking, finishing, and then this part that is not part of the final product, which is the flash. Next is press forging versus drop forging. So in case of press forging, you have uniform deformation throughout the depth, and it is a cleaner impressed as compared to jarred impressions produced in the drop forged components. And in case of press forging, it suits for smaller size components than drop forging, and as former needs higher press capacity for deforming in closed impression dies, and press capacities may range from 5 meganewton to 50 meganewton for normal applications, and as high as 600 meganewton for the special heavy duty applications. Now machine forging, so it is initially developed for making the bolt heads in the continuous fashion, and due to beneficial grain flow obtained in upsetting, it is used for making gear planks, shafts, axles, and similar parts. And the die set consists of a die and a corresponding punch or a heading tool. So here you have lowest part as anvil, then you have lower die, then preheated metal billet, then upper die. Now this will form a particular cavity, and then you have ram. In case of machine forging, the upset forging cycle. In this, movable die comes closer to stationary die to grip the stoke, and the two dies in closed position form the necessary die cavity. The punch upsets stoke to fill the die cavity, and after upsetting, punch moves back to its position, and movable grips they release the stock. And similar to drop forging, the upsetting operation is carried out in a number of stages or passes, and the material stock is moved from one stage to the other in a proper sequence till the final forging is ready. Now these are some upset or machine forged components: axle, trunnion, socket, spindle, axle housing, front end tractor spindle, ball joint housing, and shank. Now some of the forging defects. One of them is unfilled sections. So in die cavity by the flowing material due to improper design of forging die or faulty forging techniques. Cold shut, so a small crack at the corners of the forging due to improper design of the die. Example, corner and fillet radii, they are small, which in turn results in small cracks due to poor flow of materials at the corner. Scale pits, so irregular depressions on the surface of the forging, primarily due to the improper cleaning of the stock used for the forging. The oxide and scale present on the stock surface gets embedded into the finished forging surface when the forging is cleaned by pickling, and these are then seen as a depressions on the forging surface. Die shift, so it causes the cause of this is the die shift is caused by the misalignment of two die halves, making the two halves of the forging to be of improper shape. So these part, because of the movement of the die compared to one another, it can lead to misalignment and this improper final product. Next is extrusion. Now in case of extrusion, you have like plastic extrusion, the material is confined in a closed cavity. So this billet, it can be heated to particular temperature, and there can be cold extrusion as well without heating to any temperature. So there you are providing pressure from backside. In this case this is direct extrusion, so you are providing your particular pressure to this side, and there is a friction along this container walls. Okay, so here material is confined in a closed cavity, and then it is forced to flow from only one opening so that the material takes the shape of the opening. Okay, so this opening can be circular or a square shape, so depending on the requirement for the final product. Now it is used to make components which have a constant cross section over any length, and more complex parts can be obtained by extrusion than that of rolling. So in case of rolling you can only find sheets of different thickness. In case of extrusion you can get different shapes of materials as well. So as die becomes simple and easier to make. Extrusion is a single pass process, and the amount of reduction possible in extrusion is large, and generally brittle materials can also be very easily extruded. So these are typical extrusion shapes. Next is extrusion ratio. So it is defined as the ratio of cross section area of the billet to that of the extruded section. So the typical values of the extrusion ratio are 20 to 50, and the extrusion pressure for a given material depends on extrusion temperature. So if as you keep on increasing the temperature, the required pressure will reduce, because at higher temperature your material will become easier to flow because of less viscosity and friction. At reduction in area, so in one go, how much reduction in area you are considering? If you are considering very less reduction in area, you will require very less extrusion pressure. Extrusion speed, so as you keep on increasing the speed, you will require higher extrusion pressure. Now this is the classification of extrusion process. So extrusion can be hot and cold. So this will be again defined based on the recrystallization temperature. Okay, in case of hot extrusion, there will be forward extrusion and backward extrusion. In case of cold extrusion, you can have forward extrusion and backward extrusion. In case of forward, you have hydrostatic extrusion. In case of backward, you can have cold extrusion, forging and impact extrusion. In case of forward hot extrusion, so in this case the direction of flow of material is the same as that of the rim, and the friction is important because of the relative motion between the heated material, billet and a cylinder walls. Lubricants that are used to reduce this friction, so in between wall and the billet there are lubricants that to be used, and in case of low temperature, oil mixture and graphite is used, while for high temperature, molten glass for extruding steels is also used. Backward or indirect hot extrusion, so in case of forward extrusion, you are applying your force in the same direction as the in this direction, and your material is coming in the same direction. In case of backward, you are applying force in this direction and material is coming in the opposite direction. Okay, so it is called backward or indirect hot extrusion. In this case, the ram compresses the material against the container, forcing the material to flow backwards through the die in the hollow plunger or ram. Since the billet in the container remains stationary, so only the part that is experiencing any plasticity, so that will be up to this part. So there is very less part, this part is as it is, so it won't be facing any friction. Extrusion pressure is not affected by the length of the billet as friction is absent, and the problem is imposed by handling of the extruded material which is coming out through the moving frame. Next is forward cold extrusion. So it is similar to the forward hot extrusion process, except with the low extrusion ratios and high extrusion pressure. So as you are reducing the temperature, there is less amount of ductility in material, so you will be requiring higher pressures and also lesser extrusion ratio, so you can reduce the size to lower extent. It is used for simple shapes with better surface finish and mechanical properties. So in final product, you will be having a lot of plastic deformation, a lot of dislocation density, so that's why it will be having better strength, better hardness compared to hot extrusion. Impact extrusion, so it is modification of backward cold extrusion carried out by the impact force of the punch. So here you are having a punch, with the help of that you are providing particular force, and this slug, this particular material, it will take shape of this die. Okay, so here material is extruded through the gap between the punch and the die opposite to the punch movement, and it is suitable for softer materials such as aluminum and its alloys, and it is used for making the collapsible tubes for housing plate, pastes and liquids and similar articles. Cold extrusion forging. So from previous one it is very similar. Here you are providing these walls, they are thicker, and also this side walls are at particular higher height compared to this. So in the cold extrusion forging it is similar to impact extrusion, and the main difference being the side walls are much thicker and with more height, and the component is ejected this with using these ejector pins which are provided in the die. So after this punching and after it takes its shape, then this punch is removed, and with the help of ejector pin this product is removed from this die. Next is hydrostatic extrusion. So as I told earlier, here in between the billet and the container walls you'll be having a particular liquid. So this liquid can be some oils or other liquids. So here you are providing particular pressure, and this pressure is transformed to the liquid, and this liquid then transforms that pressure equally uniformly to the billet. Okay, then with using this pressure this billet is squeezed through this opening which is provided here, and this material is extruded. Next is wire drawing. So it is similar to extrusion, but here your initial material and final material both being wires. So here cross section of the bar, rod or wire is reduced by pulling it through a die opening. So the products that you have are electrical wire, cable, wire stock for fences, hangers, shopping carts, etc. You can also have rod stock for nails, screws, rivets and springs, etc. You can also have metal bars. So depending on the diameter, there are various names that are given: bar, rods and wires. So here initial diameter was D0, final is DF. Okay, and after starting stock and final stock, so here also you can apply volume balance. So volume at this side will be volume at final this side. After after putting this wire through this, so this volume will be equal. Advantages: so it has close dimensional control. So if you require particular diameter wire, then you'll be getting very high accuracy in this wire drawing, and it also has good surface finish. It has improved strength and hardness. So as the microstructure is changing after this wire drawing, so you will be getting improved strength and hardness, and also adaptability to mass production. Some of the disadvantages is that it has limited size reduction per pass. So in one pass you can reduce the size to lower amount compared to other processes, and also multiple dies are required for large size reduction. So you have to complete it in multiple passes, and also higher force is required, and if it exceeds the tensile strength further, deformation can be non-uniform. So as you know, after it your material reaches tensile strength, then it shows necking. So necking meaning there will be neck formation which will be non-uniform type of deformation. So that might occur if you exceed tensile strength. Now final chapter is on press. So why is there is a need for press? So it is to apply force on sheet metal for performing different operations through variety of mechanisms so that required size and shape can be realized. So the stress induced based on bending, shearing, compression and tension. So here in initial you can see this is the bending operation, here punching. So here punch meaning you can provide some holes or some shearing type of operation. Punching is one of the shearing type of operation. Now these are various products that can be made using pressing. So these are used in automobiles, and these are some of the vessels, and these are containers, and some of other applications are also for the bending operations. Now why do we need to study about press? So it is to understand about press construction. It helps in selection of appropriate press, which is constructional features compatibility for a given die, and also design of die which is compatible with press specification. Now selection of press, it is needed when there is new press is to be procured, and also to choose one from the available presses. The major consideration in selection of press includes tonnage, speed or stroke per minute, bed area, shut height and adjustment, stroke or travel of ram, number of presses or operation required. Next is classification of press. So there are various classifications based on these factors. So it can be based on type of frame, frame position, action, drive, suspension, tonnage, stroke, shut height, stroke per minute, die space and clutch. Now the frame and its type. So first is C frame press, other is straight sided. Now this depends on the shape of frame. So frame is one of the most noticeable feature of the press, and it provides support to the all shafts, bearings, gearings, drives, ram of press, and it is made by casting, welding of rolled steel, cast frame which is rigid, welded cheaper and tough. Now in case of C type of press, this is the C type of, here this is forming a particular C type. Okay, so it is very common and it has smaller capacity. So as you can see, this one will be having some restriction due to its shape. So there can be higher capacity in this case. While in case of straight sided press, you can go for high capacity as well. So this is again typical C frame type of presses. And in case of straight side press, here your bed and ram, this will be straight here. It won't be in form of a particular C shape. And here you will be having columns as well. So it is mainly used for large presses as its shape allows larger bed area and higher tonnage. And the box shape construction of straight sided press, it provides greater rigidity and lower deflection, and these are further grouped on the basis of shapes as solid straight side press, tie rod straight side press, arch straight side press, and pillar straight side press. And these are various parts of the press. You have bed on which you will be putting your samples, and here you have columns, and columns will be supporting gram, and above part will be crown. So straight vertical side press which has bed, columns, and crown.
Ma'am,
Yeah.
the material used for construction of bed is same for lathe and all others. I mean, is it cast iron for all?
Yeah, it should be, I think it should be cast iron as well in this case, because it will be reducing some your, in case of lathe machine also you have a lot of vibrations, so that's why, and absorbing and providing damping, you use cast iron. So here also it should be, I think, cast iron for the bed.
And for using the RAM for forging and all, which material we will be using?
For ram, I think
Yes,
it should be
like
like some steel material, should be steel, because it will be, it should have good strength as well. Depending on material that you are using, I think it will be, yeah, I'm not sure, but it should be, I think, some of the steels.
ma'am, the property desired for the RAM is it should have the more toughness value.
So ram is only the part that is moving. It, the part that will be coming into contact will be different. So that die will be coming in contact with the material. So ram should, yeah, it should have toughness as well. It should not, uh, but that not much of toughness that is required, because it is not coming in contact with the sample. So some of the properties can be, yeah, toughness can be one of the properties that is required, impact strength and other, among others.
Okay, ma'am, is this impact strength and toughness strength both are different? We will be using the CRP impact test for
Yes,
finding
it will be
the
your impact toughness. While toughness, when you using the uniaxial tensile test on, in that entire area under the curve, that will be toughness. So that toughness will be depending on the, that won't be depending on the how you are providing your, so in case of impact, your force that you are using, it is dynamic, while it is static in case of when you only say toughness.
so for the impact testing, the CRP and ISO test, we will be calculating the which strength, impact strength, or
Impact strength, impact
so impact
toughness.
strength is different from toughness. Toughness will be static.
In case of charpy, it will be dynamic. In case of, like, when you are measuring only toughness from your stress strain curve, the area under the curve, that will be static. So your in case of tensile testing, you're stretching your material at very slow, very lower slow rate, right? So that's why it is called one of the static type of testing, not dynamic. In case of charpy, you are providing the hammer that is coming on the specimen, it is at very high velocity. That's why it will be called impact strength, impact toughness.
Okay, ma'am.
Okay. Now in case of pillar type straight sides press, you will be having in the columns that are here, it will be in form of pillars. So it is similar to tie rod type of the press, and the large round pillars, they act as columns, and the crown and bed at the two ends. The different ends, you will be having bed at the lower side and crown at the opposite side, and these are held together by nuts against the shoulders, and the pillars, they guide the ram, and it is used for highest tonnage and hydraulic type of press, and these have lower cost. Now frame position, so these can be inclinable as well, which can offer many angle as covered earlier. And in case of vertical, these are also covered as straight sided gap horn adjustable bed. In case of inclined, you can have fixed at the some angle, and like simple vertical frame, it can be mounted on spatial base, and also ejection of parts by the gravity. And in case of vertical, their rods they support at other end. In case there is horizontal as well. In case of horizontal, it can be C or straight sided frame type. In this case, you have faster ejection of blanks and or scraps results in higher production rate. And the effect of gravity on ram does not affect crankshaft, and as in case of vertical frame press, crankshaft lifts the weight of the ram against gravity. However, the horizontal press, it causes ram weight more frictional effect on the guide base. Now based on action, so action refers to the number of ram on the press. So the single action, there will be one ram which is run by drive at crown or bed. In case of double action, it has inner and outer ram. In case of triple action, in addition to double ram, there is third ram located at the bed. So third ram starts to move up after other two rams they start lowering. So in this case, inner ram moves inside guideways to in guideways of outer ram, and most of the double and triple action press they most used for sheet metal drawing operations, and these are also known as toggle and draw press. Now suspension system. So press suspension is the number of points suspending the ram, and one point suspension, in this case one connecting rod and one crankshaft. For square press, 2 point suspension, so there will be two connecting rods on one crankshaft with two throws. And for long and narrow press, 3 point is rare, and 4 point suspension, in this case two connecting rods on each of two crankshaft, and these are for the large and square ram. In case of tonnage, so the maximum force that a press ram can exert, so the overloading of press can cause premature failure. Someone has joined. Okay, so in case of tonnage, maximum force that a press ram can exert, overloading of press can cause premature failure by fracture and wear, and the tonnage of hydraulic press 50 to 5,000 ton or higher can be varied by changing oil pressure, and the tonnage of mechanical press is obtained from the shear strength of crankshaft material and bearing of the crank. So tonnage of mechanical press is fixed and cannot be varied, and manufacturers supply chart for tonnage versus ram position. Stroke, so it is defined as the distance of ram movement from its up position to the down position. So in between this up position of the ram to the down position that is possible, in between this it will be stroke. So 150 stroke means 150 mm up and down movement, and it is determined by crankshaft throw, and the stroke is equal to the double of the crankshaft throw or the eccentricity of eccentric drive. It is fixed for crankshaft and eccentric drives but adjustable by hydraulic type. Next is shut height of the press. So it is the height of the opening between bed and ram in down position. It is maximum closed opening of the press. The shut height of the die of must be equal to or less than shut height of press, and it is measured when adjustment of the ram is all the way up. Next is ram adjustment and stroke per minute. So it is provided by a special screw between ram and connecting rod, and it helps to adjust the shut height of the press, and this adjustment can be used to decrease the shut height but not to increase the same. The C-frame press offers highest number of strokes per minute of all types of press, and single or double geared press have lowest stroke per minute. Next is die space. So it is the area available for mounting die on the press, and it is determined by the area of ram and bed. Drive, it is based on mechanism. Press can be categorized as ram movement devices. So based on this also there can be presses, number of gears, drives, ram, number of crankshaft or eccentric, number of gear trains between flywheel and crankshaft or eccentric. Now based on ram movement devices, mechanical type, crankshaft, eccentric, cam, toggle, rack and pinion, screw, knuckle, these are some of the parts, or it can be hydraulic type. Now based on number of crankshaft, it can be single crank or double crank. Based on number of gear drives turning crankshaft, it can be single drive, twin drive or quadruple drive. Number of gear trains between flywheel and crankshaft or eccentric, it can be direct, flywheel or non-geared, single geared, double geared or multiple geared. Now in case of hydraulic type, in this case piston and cylinder assembly is provided, and the pumping of pressurized oil is in cylinder which moves the ram, and cylinder is double action to achieve both up and down movement of ram, and there are no gears or crankshaft and eccentric required, and it offers full tonnage at all positions of ram, and in case of mechanical it offers full tonnage at bottom portion of the stroke. Now if you have any query you can ask. I'll go.
Ma'am, could you explain the blocking process after the fullering?
After fullering, blocking process.
Here the edging and blocking are
Okay, 1 second, let me. I also don't know the definition. I need to check the definition. Blocking is for refining the shape. So after bending, edging and fullering, you will be reducing the cross section of the ingot to refine its shape for the final forging process, and it is performed after the ingot has been heated and its edges have been blocked with the hammer or press.
so for the edging and fullering, it will be both reducing the cross section. For blocking, it will be refining to the final product before
Yes.
finishing.
After this, you will be removing the flash and providing some finishing. So these are various steps. Stock is just the initial part that you have. Then you provide full ring, you will be reducing the cross section. Then edging. Then after that bending. These are, in some cases you might not require bending, or you might directly go from full ring to blocking as well. Finishing, allowance and radii.
Ma'am, I have a doubt from the casting process. Can I ask it now?
Yeah, yeah.
Ma'am, for the solid string gauge, we will be considering only the okay, that mentioned. I mean, for the there is a solid string gauge and solidification string gauge, isn't it? Solid string gauge and solidification and liquid string gauge.
Yeah, yeah, yeah.
For the liquid and solid solidification, it will be dealt with by the riser. Is that correct?
Yeah,
Both
liquid shrinkage will be dealt with riser, and your
solidification.
solid shrinkage will be dealt with the your allowance that you provide, right? Solid shrinkage allowance. So you will be provide making
To the
your,
thermal
yeah.
solid shrinkage will be dealt with by using the pattern allowance, but there is a middle one called solidification shrinkage, isn't it? Solidification.
See, firstly, what happens, your density will change for liquid and solid, right? So, as you are, for example, if in water it happens differently. In water it expands, but in metals, what happens? Your solid will be having uh, will be shrinking after solidification. So that part from liquid, it will be liquid when it will be changing the temperature, then liquid shrinkage will be dealt with the riser. So extra material will be keep on coming from the riser. So after it has solidified and after its temperature is reducing, so then that shrinkage will be dealt with the your pattern allowance. So in that case, what you make your pattern little bit bigger compared to what it should be. Okay, so you and that allowance is already always fixed, like how much you require in case of lead, or how much you require in case of aluminum. So how much per the meter of the casting, that is fixed. So according to that you provide pattern allowance for solidification shrinkage, solid shrinkage.
Ma'am, I was asking about that the solid shrinkage and solidification both are different, isn't it? So, solid shrinkage is actually from the after solidification, the heat it will be coming down to the room temperature. So, the difference will be based on that thermal expansion value. We will be allocating that allowance value, isn't it?
Yeah, so that
So,
part will be, yeah, so that is the solidification shrinkage, right? That you are talking about. So that will be,
no, solid shrinkage and solidification both are different, isn't it?
solidification is the process of solidification when your liquid is converting into solid. So that is the solidification process. Solidification is not any like shrinkage, or not any uh, you know what whatever you call. So solidification is the process of converting liquid into solid in case of metal, or it can be in case of water or anything. It is not a defect.
So
Solidification
the,
yeah.
I mean, for the liquid shrinkage, it also will be there will be some density. I mean, the volume will be changing is it, and for also the salt during solidification also the temperature it will be shrinking is it.
Yeah, so with the temperature, if you, for example, if you have any metal, if you keep on heating it to very high temperature, it will be changing its shape. So thermal expansion is happening, right? So for that particular part, you are taking that into consideration with the help of pattern allowance. That is solid shrinkage. Okay, and after that liquid shrinkage, meaning some part starts to solidify earlier. So as the shrinkage is occurring in between part of the your casting will be having some shrinkage, so that part is filled with the material that is available in riser, molten metal that is in riser.
Okay, ma'am. By when considering the order of that solid shrinkage, will the brass comes in front of the steel or brass? Comparing both, which one will be placed? I mean, for some gate exam, or they have asked about the order. So the brass is having more thermal expansion having than the steel is there.
Which one has more thermal expansion? I will search it. Let me see. I think I told it in previous class. I need to check whether it was in slides. So brass solidification shrinkage, right?
Yes, yes, ma'am.
Thermal expansion should be higher in case of brass, I think. Coefficient of linear expansion of steel and brass are 10 or 19 respectively. It is higher in case of brass. So for linear expansion of steel and brass, steel is 11 multiplied by 10 to the power minus 6 per degree Celsius, while for brass it is 19 multiplied by 10 to the power minus 6 degree C per degree C. So it's higher in case of brass, so brass will be showing more expansion compared to steel.
So the pattern allowance will be more for the order can be placed by placing brass in front of the steel for pattern allowance.
Which allowance?
Pattern. The allowance that we have given for the pattern for the solid
Yeah, so
shrinkage.
your pattern will be made more bigger in case of brass, because you need to provide extra allowance because your brass will be shrinking more.
Also, there is a by considering the total shrinkage, which one will be having, which order we should be taking. I mean, considering both the liquid and the solid.
Okay, then
Which one will be which order we need to take? I mean, steel and brass. Considering steel and brass and aluminium.
okay, aluminum has more compared to brass, so it has 25 and brass at 19. So in case of aluminum you need to provide even bigger your pattern allowance. But how you're asking for comparing it with the liquid and that order, can you repeat?
I mean, for the when we are considering the solid plus liquid shrinkage, that's actually the total shrinkage, isn't it?
No, but the liquid shrinkage will be compensated by riser. For that particular part you don't provide any allowance in the pattern. Pattern will only take care of the solid shrinkage.
Okay, so if we don't need to consider the order for that volume shrinkage.
For the liquid shrinkage, no, you don't need to consider liquid shrinkage, because if it hasn't, if there will be shrinkage in the in your casting, then it won't be of any use. that can't be like compensated with the pattern allowance. Pattern allowance is for the draft allowance and all this shrinkage, all solid shrinkage part.
Okay. Ma'am, for there was a previous section that you have taken for that material size, isn't it? So for that, there is a. Can you give the timing order for that nitrading and sulfate? I mean, there are surface hardening processes in it. So for some exams, they were asking about the how much time it will be given for the comparison process were taken. In most of the lectures and book, they haven't given any timing. I mean, this much hour for the nitrading, this much hour for the carb racing, like that. So, is there any book or anything which gives us the timing for that?
Timing for that you need to take diffusion into part, right? Diffusion, how it's happening with the case of carbon and nitrogen, how fast it's diffusing. So nitrogen is smaller compared to carbon, right? So nitrogen diffuses very faster and it can diffuse at, and also you need to consider temperature as well. So nitriding is performed at lower temperatures compared to carburizing. So that also comes into picture, and how much, okay, so temperature will be there, and carbon, how much carbon is there in atmosphere that you are using for carburizing, that also comes in the formula. So for that I think you need to see, I think in Raghavan or some book you can find the what will be the diffusion formula for carburizing.
I mean, I checked for that JT Black and also there was a two other books that I have referred, they haven't given any timing, but in exams they were asking about the order, and mostly some exam they were asking for the timing value for the nitrading, cyaniding, and uh, carburizing value.
Are they asking exact time after giving most parameters, or they are asking which one in comparison wise, like which one would be faster?
In some question they are only asking about the comparison. In one of the question they have asked about the hour base. I mean, 1.1.2, 3 hours, like that.
Okay, so hours, okay, but then I think you can find like how much time is given. It can be like generalized as well. So when has sir taught these things, this lecture yet? It will be in last lectures, right? Surface hardening. So
Also in the lectures also it's not actually given. I mean, only the textbooks, but in exam they were asking this question.
so heat treatment, I think which book is that? There is one book by heat treatment and surface hardening as well, I think by the name. And if
If
one,
I don't want the correct value, I mean, if there is an approximate order, if that would be helpful.
see, it will, okay, when you're solving that, if it's asking about the comparison, then it will be based on the, I think temperature, like temperature is also standardized, and the amount of the atom. So nitrogen has smaller atoms compared to the cyanide atom and carbon atom, so I think nitriding should be faster, or that's how you need to approach the question. And I can tell you more about this in next lecture after I go through it. I think I'll try to search if I can find a book as well.
Ma'am, also which one will be more strength? I mean, cyaniding, nitrading, and comparing both three, which one will be more having more strength?
Strength will be, I think nitriding gives better strength compared to carburizing, because nitrogen will be, uh, also, I, I don't think I can tell exactly, but I don't know. I remember. I think nitriding gives better strength compared to carburizing.
Cyaniding will be placed in whether it will be on the last or in the middle of these two.
I need to check. I need to study. I can't really.
Okay.
See some nitrided steels, carburized steels. It's changing with the case depth. If case depth is increasing, then okay, carburizing. With the case depth, it's changing. Like if the case depth is increasing, then carburized steels has higher hardness compared to the nitrided steel, and at lower case depth, some nitrided steels has higher hardness compared to carburized. And they haven't compared car- cyaniding. They haven't compared cyaniding. Cyaniding they haven't given. It's previous year question, then they must have given the some explanation as well, right?
But actually, it was asked for the railway exam. So I don't know. It was I got it from the textbook apparently. The some most of the explanation that given in that some of them are actually wrong, and in different places they are giving different values.
Okay. I think for this you need to go through some heat treatment based
So I
questions.
checked the JD Black and also the glue. There was text for Groover, and in both of them they haven't given the and some textbook are starting with the S. I don't remember the name.
Okay. Okay, I can look into it and tell next week. I think I can't find like the comparison of all these three, strength wise and the diffusion wise.
Okay. Also, for the oxidizing, is it actually done by only heating it to the oxidizing temperature? If it is reached the oxidizing temperature, can we say the we have done the oxidizing?
Yeah, austenizing meaning taking your steel into austenite, yeah, austenite part.
So we don't need to quench it. When we quench it from the outside, it will be going to the martensite.
Yeah, yeah. It
Okay.
can turn into martensite and some part can be retained austenite as well, depending on the composition of steel.
Can we get the metal locked into the austenitic value by after cooling?
Can you repeat?
I mean, at the lower temperature, can we lock this metal to the austenite
Yeah,
values?
yeah. So in some steels, what happens? You have austenitic steels as well. So in those, what you do, you austenite stabilizers are there. Nickel, manganese, and some of these alloying elements, they increase the area of the that austenite part. Okay, so when you draw your phase diagram, you draw between for iron and carbon, right? So for iron and nickel and iron and manganese, when you will be drawing those, this phase, this area will keep on increasing, this austenite area, and it comes to even room temperature in some cases. Okay, so some steels can have austenite at room temperature as well.
Ma'am, when we are studying that triple T diagram, whether this austenatic locking will be happening. I mean, if we austenize the steel and quench it, we will be getting the martensite
Yeah.
by without touching that nose, isn't it? So this locking of the ozonates happen when we are cooling it more rate than the martensite, or is that correct? If we cool it more than the rate of that martensite
It will
formation,
cool faster compared to the nose temperature. Nose, you have critical rate at the nose, right? So if you cool faster than that, then you will be getting martensite. If you cool slower, then you will be getting into perlitic region.
so locking of this oscillate won't be happening in these two condition. I mean, the if we cool it faster than the martensite, we won't be getting any oscillate.
No,
It
austenite is austenite. You will be getting retained austenite here. You can get simple austenite as well in case of by changing the altering the alloying elements in your material. So that will be completely different compared to what you are trying to achieve here. So here what we are doing, we are changing the cooling parameters, cooling rate parameters. With that you are getting martensite and retained austenite. So this retained austenite will be lower, I mean 5 up to 5% or so. This will also be depending on your alloying elements.
okay, ma'am. So it will be on that allowing diagram that two curves will be coming.
Yeah, that as well as if you have very high nickel amount, then also your entire phase diagram will also be changing. You'll be having a lot of like austenite in your even up to room temperature. If you have manganese also at higher uh, amounts. Okay. Okay, till
Okay, ma'am.
5 I'll be, yeah, completing the class today. Yeah. Okay. Okay.